some series and integral calculus or some series through integral calculus. Some series and integral calculus. How we can calculate summation of a series through integral calculus? This is the topic that is generally not available in the book. People try to solve it through algebra only. When someone say, what is 1 plus 2 plus 3 plus 4 plus n? It is n plus 1 by 2. Anyone would say. It is n plus 1 by 2. We'll try. 1 plus 2 plus 3 plus 4 plus 5 up to n. Let's say summation is s. Summation is s. Then s equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 up to n. I now what is this? What is the summation 1 plus 2 plus 3? Okay, let's write s again. S equal to 1 plus 2 plus. Now let's write s again by inverting it. Inverting it means the last term will come at the beginning and beginning term will go at the end. So it will become n plus n minus 1 plus 1. This is how it will become. Now add it. 2s 2s equal to n with 1, n plus 1, n minus 1 with 2, then n plus 1, n minus 3, n minus 2 with 3, n plus 1. At the end, it is 1 with the n plus 1. All are n plus 1. 2s equal to n 2s equal to n plus 1, n plus 1, n plus 1, n times. 2s equal to n into n plus 1. S equal to n plus 1 by 2. Makes sense? Okay. Let's try now. What you want? I want hope 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power n. Now tell me. Okay, it's not very difficult. S equal to 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power n. Yeah, okay. Let's write s again. Multiply with 2 now. S equal to, we understood. Multiply 2 on both sides. 2s equal to 2 to the power 0 will become 2 to the power 1, 2 to the power 2. At the end, it will become 2 to the power n plus 1. Make sense? Yeah, makes sense. Now subtract this. 2 into s minus s. It will become s and in bracket 2 minus 1. Yeah, equal to that side. If I subtract, then everything will go away. What will remain here? What will remain here is the first term in the first summation, that is 2 to the power 0. And this side 2 to the power n plus 1. This would remain now. Now we have s in bracket 2 minus 1 equal to 2 to the power n plus 1 minus 2 to the power 0. S equal to 2 to the power n plus 1 minus 2 to the power 0 by 2 minus 1. If I take a, what is summation series a to the power 0, a to the power 1 plus a to the power n? The answer will be a to the power n plus 1 minus 1 by a minus 1. Oh, why you need calculus? Okay, can we try third one? What is the problem here? The problem here is that everywhere fundamental is different. Sometimes you have to invert it and then add it. Sometimes you have to multiply by something, then subtract it. Third time you will have to divide by something, then do something. Then if how many summation series you know? There are infinite summation series, not one. Infinite way someone will remember. Infinite way, then he will die there one. Is there a single way to calculate all the summation series? And there is a single way, there is a single name, and that is called calculus, integral calculus. Yes, it is possible to calculate through integral calculus. Okay, how it is possible, that we will see. I was trying one by 1 by 1 plus 1 by 2 plus 1 by 3. Later in session we will see it. 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5. That falls in equation fx equal to 1 by x, where x is going 1, 2, 3, 4. Okay, I was saying we will talk about it. This is something that is coming in logarithmic, and may need to use the Taylor series or Maclaurin series. So there, Mr. Sir Taylor or Sir Maclaurin, that we need. Mind-blowing invention by Sir Taylor and Sir Maclaurin. Okay, I won't say that there are no other people who are not in parallel to Sir Taylor. I don't know who came first. Sir Taylor came first or Sir Fourier came first from France. One Sir Fourier, he is a person who had was gifted some separate brain. Means you can have electronic signal, anything electronic signal that is combined through sinusoidal signal. Amazing, mind-blowing thing that he talked about. And I have personally proved it in laboratory. If I combine many sinusoidal waves of different frequency, different amplitude, and different phase difference, if you add all the sinusoidal wave in that fashion, you can indeed generate a kind of square wave. I have generated it. It's really possible to generate a square wave out of sinusoidal waves in different harmonics, I mean, in different frequency, different phase, and different amplitude. Mind blowing, amazing. These people, they carry different kind of brain. This is what happened. France has given many things to the world. Pascal computer language, I believe, it was written by one French people only. Means they have given a lot to the world. That is for sure. Very distinguished country, France is. Anyway, now the question is arising that can we do everything through integral calculus? All the summation, certainly we can do all the summation through integral calculus. Then can you try a to the power x? Okay, what do you mean? A to the power x means a to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power 3 plus a to the power x or a to the power x minus 1 for a to the power t minus 1. What is t? Small t. T is a small t, that is any number. A to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power in bracket t minus 1. Means I'm trying to make it as total t terms, not t plus 1 term. T terms. Can someone add it? Okay. The first concept here, the first rule is divide it into t different parts or a to the power n minus 1. Someone can write it that manner. At the end, it is a to the power n minus 1. Divide it into t part or n parts. Now let's tackle part by part. First part is a to the power 0. Second part is a to the power 1. Like that, we have last part is a to the power n minus 1. Okay, part by part. Can I see all as same? That is the first thing that someone has to try with our algorithm. The algorithm that we are placing now. Can we divide this issue into n different parts? Okay, can someone divide it into n different parts? Yeah, we can divide it into n different parts. First part is a to the power 0, that is 1. Second, so anything, any summation what we are seeing, we have to divide first into n different parts and make all part look same. How all part can look same? A to the power 0 is different than a to the power 1, a to the power 2, a to the power 3. This falls, whatever we are talking here, doing everything through integral calculus, this falls in grand design in the electronics industry and software industry. Grand design means how we can do a bigger design, how we can do higher level distributed designing. High level distributed designing is made up of you cannot duplicate anything. That is the highest level to highest highest possible distributed design. We will place a paper on that. How someone can design any software or an electronic circuit, large scale, this is a better word, large scale electronic circuit or the software designing, how someone can proceed on this. This can be used anywhere. Nothing should be duplicated. Whatever, like the way we are saying, everything, every summation what we are doing, through algebraic way, everywhere things are different. That cannot come under large scale design. Large scale designing, you have to understand each and every unique piece in the designing, each and every unique piece in design. And you have to place gate by gate. What do you mean by gate by gate? Gate by gate, if I place a larger scale designing, then all components, unique components, they work exactly. Means all components will be orthogonal components. Orthogonal components means they do not depend upon each other. What is they do not depend? If consider I am designing a software or electronic circuit, and then in electronic circuit, I divide into n grouping, different n grouping, different n logical unit. If I divide into n different n logical unit, all n logical unit should do something that is separate from other. There should not be any overlapping over there. Overlapping over there, if I talk in software term, if I screw one component, consider I have n number of components. I am very in love. I am very inclined to a component, kth component. I have n number of components in software that I have designed, and I have kth component. Now kth component, I took a screwdriver and I am now screwing it. I must make sure that other n minus k component they are exactly stand and still. There no change in is seen there. It won't change in heat. It won't change in color. They will just stand like nothing is happening to them. This is called perfect designing. All should be orthogonal to each other. 90 degree to each other, they would not change. Why I said gate means if anyone is using any component, then he can come out of the building. All the components when we design, all should be gate of the building. Anyone should to use any component and he should come out of the building. Coming out of the building means he is getting the target. He is finding the target, what he wants to achieve. So any component in the software, it must give the output. It must give the output. No, these are the library components and you have to use in your software. Completely wrong. All components in the software, what I'm dividing, all should be independent in a manner that I can use any one component to have a full-fledged software. There will be input and there will be output, and that output must be fed to another component. That word should not be there. Okay, I should be able to use that output of any component as output of a software. Okay, this is another thing. If I need very complicated output, then I will use a series of components, or they will be connected, not maybe in series like chain of responsibility is a design behavioral design pattern out of gang of 4 design pattern, 23 design pattern. The first one is chain of responsibility only. In behavioral, I'll chain all the components and start feeding output to the input. That can be one thing. Another can be hierarchical also in a tree manner. Tree manner means one output is being fed to many components and their output. But nothing should be repeated. One component should not fit at 5 different places. This is what the concept is. Okay, anyway, these are the larger scale. So if I am using integral calculus to compute it, then there should not be 5 ways that you can use integral calculus to have the series. There should be only one. If I have a problem to solve summation series, there should be only one. It's not that the algebra we talk, okay, that problem. Now I'm remembering that I had to divide or I have to subtract and then I have to multiply with this and then that way, no one can go for 30 n number of solutions. If I have a disease, then for cancer, for God's sake, no one should no one should hear these kind of diseases. Miss cancer and these kind of diseases, if someone is getting, it's not only swelling. The way it pains after some time, the way it pains, that person only understand what is called disease. What is called disease? Any disease. Okay. Now I should not have that. Okay, if you have a cancer, then this medicine. If you have a tuberculosis, then this medicine. If you have a hair falling problem, then this medicine. Okay, beyond this disease, I cannot take the name. Those that much dangerous. Anyway, even God should forget these names. Some diseases are like that. Anyway, if there are dementia, person is forgetting, then this is the disease. Then this, but how many medicine you will remember? There should be something that there should be only one medicine to all. How? Yes, you are kidding or what? There are infinite diseases. How can there will be one medicine to all diseases? If you take a medicine, that will be good for your digestion. But if you take another medicine, it will be good for your eye. Because one needs vitamin D, or one needs vitamin A, one needs vitamin B complex, vitamin B2, B12, one needs iron, one needs copper, one needs calcium, one need, if bone is weak, then you need to give calcium. If a stomach digestion is not good, then you have to give something else. If you want to wash your teeth, then you need a toothpaste. What is that? That name is Dantkanti. You have to use some Dantkanti. Okay, but if you need something else, if you need to make your bone stronger, then you have to use some other calcium. There cannot be one medicine to. Why? How you are kidding or what? One medicine can have one particular thing. There not can be 50 medicine, not possible. There cannot be one medicine for all the problem. No, I want one medicine for all the problem. I'm not going to run for the here and there for the medicine and then this doctor. Give me one, not possible. Is it really possible? If someone makes it possible that only one medicine for all diseases, then he understands the disease. Then he really understands the disease. Okay, what do you mean? Eye is different, nose is different, mouth is different, stomach is different, skin is different. Everything is made with different kind of chemical. How one disease can solve it? I won't go beyond it. If I go beyond it, the person who is hearing this, listening to it, his head will start spinning, spinning. So better up till here only. Okay, anyway. So there cannot be a single medicine for all the disease. If it is possible that the person really understands the concept of the physiology or called body. Anyway, now we are talking about how we solve a to the power 0 to a to the power n minus 1. Now divide into n different parts, and let's say one particular part is a to the power x. Next part is also a to the power x. Next part is also a to the power x. What are you doing? Now I am solving part by part. Each part is a to the power x. But I said each part, you said each part is different. No, all parts are same, only a to the power x, a to the power x, where x is variable. Now I am writing on my notebook a to the power x, a to the power x, a to the power x, a to the power x. Looks like I have to sum all a to the power x x times a to the power x into x. If I have 5 times, I have to add a to the power x, a to the power x into 5, a to the power x into x, a to the power x into dx, where x will go 0 to n. If x will go, there are n number of a, start with 0 to n minus 1. So it will go 0 to n. The way it is, if I add 5 4 times, then 5 into 4, 5 into x, 5 dx, where dx will go 0 to 4 times. Similarly, if I have to add n times, 0 to n, a to the power x dx. What is a to the power x dx? Then that is a to the power x divided by logarithmic of a. This is what the summation is. But you said it is a to the power n. I'm sorry, we will put limit now. A to the power, we are saying a to the power x by logarithmic of a. 0, 0 to n. So it will become a to the power n minus 1 by logarithmic of a. Okay, but the actual solution is a to the power n minus 1 by a minus 1. Okay, I don't agree with you. Your integral calculus is waste, because whatever you are saying, I'm okay with you that with every problem you can solve through integral calculus. But I need perfect solution. This kacha bacha means hazy wazy will not work. Okay, what we talk now, this is called repeated summation. Repeated summation it also repeated summation lands up into integral calculus. First, we made all parts look same. Then we went for repeated addition, multiplication, integration, and then limit, and we solved it. But it is not perfect. A to the power n minus 1 by logarithmic of a, natural log of a. It should have been a to the power n minus 1 by a minus 1. That is the result. Let's try our another magic wand, that is the successive approximation by integral calculus. Successive, but it gave a hint at least that it is a to the power n minus 1 by logarithmic of a. Someone has to prove logarithmic of a is nothing but a minus 1 only. Okay, I mean, someone can try. Someone can try. Okay, if I say y equal to y equal to log of a, then how much? Someone can try. Okay, if there are some corner conditions, then logarithm of a will become a minus 1. That is true. Okay, if I say y equal to logarithmic of a, then e to the power y equal to a. E to the power y minus 1 equal to a minus 1. What is e to the power y minus e to the power y minus 1? Something like that. Someone can try. Anyway, now let's try a kind of let's try the successive approximation. Successive approximation says many times we have demonstrated successive approximation. Successive approximation say, okay, now someone will say, looks like you have found a algebraic equation. Yeah, this is an algebraic equation. I had to add a to the power 0 plus a to the power 1, a to the power n minus 1. Each part I set a to the power x. Means I have algebraic equation a to the power x. Okay, but a to the power x is not a continuous function. It is a kind of it is a discrete function. Means if this is x-axis, this is origin, this is x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then this is a to the power x. This is a to the power x. Means when x is 0, then its value is 1. So it will be little bit in offset. A to the power x. Okay, if it is, if this is a to the power x, if this is a to the power x, then it is sampled at x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, first x equal to 0, it is 1. Then a to the power 1, a to the power. It is not a continuous function, it is a discrete function. But if I touch all the top points of all the vertical bar, when x equal to 0, vertical bar is 1. When x equal to 1, vertical bar is a. When x equal to 2, vertical bar is a to the power 2. If I add all the top point of vertical, it will result into a line like this, and that is a to the power of x. But it is not a continuous function, it is a discrete function. Okay, fx. Let's say there is another function called gx. It is a continuous function. If it is a continuous function, then I can divide this gx into separate sub area from x to from x equal to 0 to x equal to 1. There is a sub area like this underneath gx. From x equal to 1 to x equal to 2, there is a sub area like this. Now, the way we have a to the power 0 to a to the power n minus 1, we have n vertical bar, we have n sub area, where last sub area will go from x equal to n minus 1 to x equal to n minus 1 plus 1 up to n. We have now n sub area. If I add all this sub area, it will become gx dx, integration from lower limit to higher limit in x. That will give the full sub area underneath it, which I am dividing into separate sub area. If I take a particular x value, at this x, what is your fx? Fx means a to the power x. My fx is the height at this point, at any x, that is a to the power x. Okay, what about gx? Gx is g of x, but I don't know what is gx. Okay, what is the equivalent of fx at x equal to x? That is a to the power x. What is equivalent in gx? Then it is limit x to x plus 1 gx dx, that sub area between x equal to x equal to x plus 1. This sub area, this sub area, this sub area is should be same as what sub area. This is gx. Gx sub area between x equal to x equal to x plus 1. This sub area should be exactly same as what I have fx at x equal to x. If that is same, then for next x, fx at x equal to x plus 1, the next sub area in gx will be same. If all are same, pillar by pillar, then both are exactly same. Means I have found the gx and then I can start using it. This is what we keep on telling in every session. Now we have fx equal to, the actual solution is summation of x from 0 to n minus 1 fx a to the power x fx. If I sum like this, it should be equal to limit x equal to minimum to maximum gx dx. Then I get the gx and I can solve it. If I go pillar by pillar, vertical by vertical, the vertical at x equal to x, fx is a to the power x, should be same as limit x equal to x plus 1, gx dx. I have to find gx dx. If fx equal to gx dx, then gx will be dfx by dx. What is d of a to the power x by dx? That will be logarithmic of a into a to the power x. Now don't tell me how you say differentiation of a to the power x is logarithmic of a. Okay, someone can try. Y equal to a to the power x, dy by dx, of y equal to a to the power x, logarithmic of a equal to of y equal to a to the power x, log of y with base a equal to x. Log of y with base a is same as log of y with base e divided by log of a with base e. Log of y with base e equal to log of a with base e into x. Okay, dy, if I take dy by dx, means differentiate with x on both sides, log of y with base e will become 1 by y dy by dx equal to logarithmic of a, gone. Differentiation of x is nothing. Makes sense? Now dy by dx equal to logarithmic of a into y is a to the power x, dy by dx equal to logarithmic of natural log of a into a to the power x. Okay, so now we have fx equal to gx dx, dx equal to dfx by dx equal to logarithmic of a into fx a to the power x. We found it gx. Let's try now. Logarithmic of a to the power x dx, and limit is x to x plus 1. Okay, if that is the case, then it will become now integration of a to the power x is a to the power x by logarithmic of a, both logarithmic gone away, a to the power x remain. Now we will set x to x plus 1 limit, then it will come a to the power x plus 1 minus a to the power x. A to the power x I'll keep outside and it will become a minus 1. Okay, what do you want? I want a to the power x. What you got? A to the power x in bracket a minus 1. A minus 1 is unwanted now. Okay, so we will divide with a minus 1 and we'll try again. So now we have to try gx as logarithmic of a by a minus 1 a to the power x. It will become a to the power x by logarithmic of a will go away. A to the power x by a minus 1, a to the power x, if I keep limit x to x plus 1, it will become a to the power x, a minus 1, a minus 1, a. We got ax equal to ax. Okay, so we got gx. We got gx. What is your gx? Gx is logarithmic of a by a minus 1 into a to the power x. If you got gx, if I integrate from begin to end, you will get the result. Yes, we will get the result. Let's try now. Okay, now we started with x equal to 0 and x equal to n minus 1. If I take x equal to 0 and x equal to 1, one subsection up till n minus 1 to n minus 2 to n minus 1, we will have n minus 1 section, not n section. We want n section because there are n verticals are there. To have n section, we will not take n minus 1 to n. Though n is not there, still we will take the last as like that. Means I have to integrate from 0 to n to have the full thing. Integration 0 to n, logarithmic of a by a minus 1, a to the power x. Now it will become logarithmic of a by a minus 1. Integration will be a to the power x by logarithmic of a, logarithmic of a, logarithmic of a will go away. Result will be a to the power x by a minus 1. Limit will be 0 to n, a to the power n minus 1 by a minus 1. This is called successive integration. Step by step, you have to match fx with the gx, dx and x to x plus 1 or whatever. We have given many examples. Somebody who is very avid watcher, he will say, boss, you tried 0 to 1, 1 to x plus 1, right hand side. Try left hand side. X minus 1 to x, not sure. It should come same as your fundamental. We'll try now. A to the power x. Now we have gx as logarithmic of a to the power x. We try from there. Integration from x minus 1 to x. Then it will become a to the power x by logarithmic of a multiplied by logarithmic of a, logarithmic will go away. A to the power x, x minus 1 to x. If I set the limit, it will become a to the power x minus a to the power x minus 1. Now someone will say, now you are caught. It is difficult. If I take it, it is a to the power x and bracket 1 minus a to the power minus 1. Someone will say you have got a to the power x and in bracket 1 minus a to the power minus 1. Okay. Anyway, now result we should target is a to the power x. We are getting a to the power x bracket 1 minus a to the power 1 minus a to the power minus 1 is constant, is extra. So I have to divide with it. So now we will start gx as logarithmic of a to the power x by 1 minus a to the power minus 1. If I do integration again, it will become a to the power x by logarithmic of a. Log will go away. A to the power x by 1 minus a to the power minus 1. Limit x minus 1 to x. If I set a to the power x minus a to the power x minus 1, it will come exactly as a to the power x 1 minus a to the power minus 1 by 1 minus a to the power minus 1. Solved. It will come as a to the power x. This is what we want. A to the power x1. Okay, thank you very much. Very nice. So your gx is gx is logarithmic of a by 1 minus a to the power minus 1 into a to the power x. Yeah, this is the gx. Now set the limit. Now we are trying left side. Left side. This is 0. The left side. So limit will start from minus 1. Minus 1 and it will go till n minus 1. Minus 1 to 0, one subsection of gx, like that there will be n subsection and last subsection will be n minus 2 to n minus 1. Now I have to add all, so limit will be minus 1 to n minus 1. Can someone imagine it? The limit is minus 1 to n minus 1. Logarithmic of a to the power x by 1 minus a to the power minus 1 dx. If someone integrates, it will become logarithmic of a to the power x by logarithmic of a into, in denominator, 1 minus a to the power minus 1. Logarithmic of a will go a to the power x by 1 minus a to the power minus 1. Limit is minus 1 to n minus 1. First it will become a to the power n minus 1 minus a to the power minus 1. Okay, if it is like that, okay, then I will multiply it with a, I think so, a, then it will become a. I'll multiply with the a as numerator and I'll multiply with the a as denominator, a by a. If I multiply numerator with the a, it will become a to the power n minus 1. A to the power minus 1 into a is 1. A to the power n minus 1 divided by 1 minus a to the power minus 1 whole I have to multiply with the way, because we have used a by a, I have to multiply. Then it will be up, it will become a minus 1. Same thing, a to the power n minus 1 divided by a minus 1, with left side also, right side also. It is coming the same. Means this is perfect. The summation of series a to the power 0 plus a to the power 1 plus a to the power 2 up till a to the power n minus 1 is a to the power n minus 1 by a minus 1. Everything, whatever we are trying to solve, everything can be achieved through integral calculus. Same methodology, same steps. Is it not a boon? Then what else it is? What else it is? Now, student, for any summation series, he has to follow some steps. That is the generic step. No need to go with the if there are 30 summations and 30 way to understand it. This is a boon to students and this is boon to researchers also. Amazing, mind blowing. This is not available in any of the book. Anyone can try. Please don't mind supporting us. +91 in the country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.